Hi, Victor. How does a NLP system know about grammatical and closely related words and phrases?
Okay, NLU and NLP uses two methods really. They're all about resolving what's called the resolution of these words. And the first one is phonology. So it's really about how words sound, how they're formed, and specific physical properties of that word. So you might think of any word and its etymology. So like, where did it come from? How does it actually come out of people's mouths? And what is the sound of this word? And what does it add to the entire sentence? So in language, we sort of just innately do this, but obviously computer doesn't just innately understand language. So it has to really start looking at the whole metadata around a word and a sentence. And lastly, the last part is morphology. So you can think of different versions of a word, right? So the easiest one is to think of verbs, because you have present tense, past tense, future tense, all this other stuff. So you may have a verb that has morphed, and you don't have to teach the NLP system or NLU system every possible word in the world. You literally just have to teach it how to get back to the root of the words, how to morph the word back, and then you're at a place where it has an understanding of the actual word because it knows the root word. And morphology also gives you a little bit more about like grammatical properties of text. All of that wrapped up, so all of those versions of analyses and resolution do give a very good and strong understanding to NLU. The last part that we often forget to talk about is that you need full-on representation. And representation is, how do you turn all of the things that the NLP system, NLU system read into something that's machine readable now? Because text is not really machine readable. And there are generally two good methods for this. There's symbolic representation, where you might turn, let's say, the word semantic or syntax into 1 and 2, because those are symbols. It's very simple. So you're treating them as, whenever I see the word semantic, it's going to be a 1. Whenever I see the word syntax, it's going to be 2. So then you end up with a representation of your content in something that a machine can. The other way that you do it is a statistical representation, and it's usually a probabilistic model. So you can imagine that the word "the" is like all over English language text, and the word "is" as well, whereas the word porcupine probably is not, right? So there's going to be a statistical model that shows sort of like the prevalence of words in text, and then that sort of hints at topics and hints at meanings. So it's a big mixed bag of a lot of techniques to really get at the understanding of text and the understanding of content. And that's what makes, NLU systems, including chatbots, really impressive and really cool AI, is that machines aren't inherently built to understand us. It's really us, we make machines that are going to try to understand us. Quite a bit of help. You can see that machines will and are capable of understanding what we say, what we write, and how we write it. It's just a matter of giving them enough horsepower to compete through it. Yeah. Wow. So there you have it. We've talked a little bit about NLU. We've gone from super high level to a little more, in depth.